Very good morning. Today, we are going to see about a economic load dispatch problem with considering losses. Take down this problem. A system consists of two power plants connected by a transmission line. The total load located at the plant 2 is shown in the figure. The data of evaluating loss coefficients consists of information that power transfer of 100 megawatt from station 1 to station 2 results in total loss of 8 megawatt. Find the required generation at each station and power received by the load when lambda of the system is 100 per megawatt hour. The ICFs, like incremental fuel cost of two plants, are given here. That is DC1 divided by DP1 is equal to 0.12 PG1 plus 65 rupees per megawatt hour. Then DC2 divided by DP2 is equal to 0.2 PG2 plus 25 rupees per megawatt hour. There are two plants are there, plant 1 and plant 2, and two buses are there, bus 1 and bus 2, and bus 2 is connected to the load when 212.5 megawatt received by the load, that is demand. Find the savings in rupees per hour obtained by coordinating the transmission losses rather than neglecting in determining the load division between the plants. So that is the problem given. The previous problem that also we have solved, in that this lambda value is not given. Lambda value we found out the previous value, that also, that video also I'll give in the description. You can watch that video also. Here lambda value already it is given. So no need of finding out the lambda. So this problem is somewhat simple than our previous problem. The solution, the PL equation formulation, PL is equal to PG1 into PG2 matrix into B11, B12, B21, B22 into PG1, PG2. This we need to just multiply since the load is at the bus number 2. So PG2 will not have effect on PL. So this we need to neglect. Actually, this wrongly neglected. So this you need to neglect. So PL is equal to B11 into PG1 square. Take this as equation number 1. So B11 and PG1 squared already given in the problem. This equation, how it becomes now, while multiplying this, so you'll get the equation like this. So PG1 squared already given in the problem as 100 megawatt. So 100 megawatt, that is data for evaluating loss coefficient, consists of information that power transfer from 100 megawatt from station 1 to 2. So 100 megawatt is given and total loss also given. So 100 megawatt, we are just substituting here. So 100 square. So if you calculate B11 is equal to 8 divided by 100 squared, B11 is equal to 0.0008 megawatt inverse. So this is the B11. Now substitute B11 in this power loss equation. So PL is equal to power loss equation is equal to 0.0008 into PG1 square. So this is the power loss equation. Next, what is the condition for optimality? That already you know, L1 into DC1 divided by DPG1 is equal to L2 into DC2 divided by DPG2 is equal to lambda. Since PL is a function of P1 alone. So PL is the function of P1 alone. So L1 is equal to 1 divided by 1 minus dou PL divided by dou PG1. Now we are differentiating dou like a PL equation with respect to PG1. So while differentiating, you'll get 0.0016 P1. So this equation is there now. So this equation we are differentiating with respect to PG1. So this into this, that is 0.008 into 2 into PG1. So that only we are writing over here. Next, similarly, L2 is equal to 1 divided by 1 minus dou PL divided by dou PG2. So dou PG2 is not there in PL equation. So if you see this PL equation, there is no dou PG, the PG2. Sorry, PG2. So so you can't differentiate. So that becomes 0. So this terms becomes 0 here. So here what we are doing is just substituting here 1 divided by 1 minus 0 is like 1. So L2 is equal to 1. So L1 also we calculated, L2 also we calculate. Just you need to substitute in this optimality condition. That is L1 into CG1 divided by dPG1 is equal to L2 into dCG2 divided by dPG2 is equal to lambda. So just substitute L1. So already calculated 1 divided by 1 minus 0.0016 P1 into this DC divided by dPG1 already given. That is 0.12 P1 plus 65 is equal to 100. That is lambda is nothing but 100 that is given in the problem. So it is very simple. So here just like simplify this equation, you can get a PG1. So PG1 is equal to 125 megawatt. You just tell in the comment whether you got the same answer or not. Similarly, L2 into DC2 divided by dPG2 is equal to lambda. This L2 is 1. This DC2 divided by dPG2 that we need to substitute over here. Already we calculated, that is already given in the problem, that is 0.25 PG2 plus 75, that is equal to 100. That is lambda is equal to 100. So here while simplifying, and we'll get the PG2 as 100 megawatt. Now PG1 is equal to PG2 is equal to PD plus PL. So PD is given in the problem as 125 megawatt. PL also given as 100 megawatt. So just like add, you'll get the 225 megawatt. 225 megawatt is nothing but PG1 plus PG2. So what is PD here? So sorry, yeah, PD here means how to calculate PD. PD is equal to this total minus P. Okay, that is PD is nothing but 225. Okay, then 225 is PD. So you are just substituting here. So you will get PD is equal to this PG1 plus PG2 is equal to PD. So PD is equal to 225 minus P. So 225 minus PL already that equation you have, that is 0.0008 PG1 square. Just what you need to do is you need to substitute PG1 as 125 megawatt, because already we calculated no 125 megawatt. Here we calculated no. Similarly, you need to substitute, and now we will get the demand as 212.5 megawatt. So PG1 and PG2 satisfies the power demand also. Okay, this two PG1 and PG2 is satisfies the power demand. And this PD also given in the problem, that is 212.5 megawatt. 212.5 megawatt. Just we are checking, okay, whether we are getting the same demand or not. Just we are checking. So we have got the same PD. Now what you need to do is without losses you need to do. So with the losses we consider without losses the same. IC1 is equal to IC2 is equal to lambda. This equation already given, that is DC1 divided by dP1, that is DC2 divided by dP2 is equal to lambda. So here you need to equate it to this this equation. You just take this side 0.12 PG1, say here minus 0. PG2. Here this 65 goes this side, means it is minus 40 will come. This equation this you take as one equation, and PG1 plus PG2 is equal to 212.5 megawatt. So that is PD. The demand is already given. By solving this two equation, we are getting the answer as PG1 is equal to 7.8125 megawatt and PG2 as 204.6875 megawatt. Now we need to calculate the savings obtained. How to calculate the savings obtained? Because already asked in the problem. Asked in the problems, how to calculate the savings obtained means here DC1 divided by dPG1, that is given. So C1 is equal to integration of that DC1 divided by dPG1 into dPG1. That is This is already given in the problem, that is 0.12 PG1 plus 65 into PG1. Now we are taking the limits. Limits how we are taking is lower limits that 125 megawatt already we got in the problem, that is with the losses, that we are taking the upper limit, and lower limit we are taking as whatever we calculated here, that is 7.8125 megawatt, that we are substituting here. Just we are substituting this upper limit and lower limit, integrating. So while integrating this will become 0.12 PG1 square divided by 2 plus 65 into PG1. So we need to substitute the upper limit and lower limit. So upper limit if you substitute and lower limit if you substitute, you will get the answer as 9062.5 minus 466.787. Just subtracted, you will get the answer as 8595.712 rupees per hour. That is the cost C1, cost function 1. C1 is equal to 8595.712 rupees per hour. So you just tell in the comment whether you got the same answer or not. Similarly, we need to calculate C2. C2, the same thing we are taking. So here, what we are doing is we are taking this this limit, that is 100 megawatt and 204.6475 megawatt. And the same thing, whatever we did for C1. So this is 0.2 PG square divided by 2 plus 25 PG2. So you need to substitute the upper limit and lower limit. So while substituting the upper limit and lower limit, we are getting the answer as minus 806.8847 we are getting. So that is rupees per hour we are getting. So what is the total savings? Total savings CT is equal to C1 plus C2. So this is 8595.712 minus 5806.8847. Just calculated, we will get the total saving as 2788.8272 rupees per hour. So for the given generating system, we got the savings as 2788.8272 rupees per hour for lambda is equal to 100 rupees per megawatt hour compared to the system without considering the losses. So this we are comparing with the system compared to the without considering losses. So that so we are getting the savings as rupees 2788.8272 rupees per hour. So as I said before, this is mentioned, this problem is mentioned in rupees per hour. Sometimes your own currency. So whoever is watching the video, your own currencies, dollars or yen or euros. So whatever the currencies that is given to the particular problem, you need to solve similar. So the methodology is same. The currencies might be varied. That's all. So methodology is same. This is how you need to solve this problem.